We are continuing our information about scientific notation, section 8.4. And so we're going to order our numbers from least to greatest. And when you write your answers, they must be in the original format that was given to you. I will take off on your test if you don't. If I have to figure out what number you're talking about, I will take off. They must be back in the original format they were given. But in order to put them in order, so that we can put them in order from least to greatest, we are going to use scientific notation. Could you do this and putting them in standard form? Yes, you would have done that in 4th grade. Now you're in Algebra 1, Advanced Algebra 1, and we are going to do it using scientific notation. So I want to know how you write 93 million in scientific notation, first of all. Okay, 93 million scientific notation. Katie? 9.3 times 10 to the 7th. Here we have 9.2 times 10 to the 6th. Is that scientific notation?
Yes.
Yes. And could I have 9,028,000 in scientific notation, please? Josh?
9.2 times 10 to the 6th.
Times 10 to the 6th. All right. So we have our 3 numbers up here that we are looking at. This one, and this one. And what we are going to have to do is we're going to be comparing those numbers based on their exponent on the 10, as well as the constant. If you look at them, I have 9.3 times 10 to the 7th. I have 9.2 times 10 to the 6th. And I have 9.028 times 10 to the 6th. First thing you do is look at their exponent. Which one has the biggest exponent? 9.3 times 10 to the 7th. That's our largest number. Okay? This is our largest one. Which one has the smallest exponent? The smallest exponent. Jack?
Both the other ones.
Both of the other ones have the same exponent, exactly. So now, since they both have the same exponent, I need to look at the numbers, the constant. So I need to look at 9.2 and 9.028. Which one's smaller, 9.028 or 9.2, class?
9.028.
So this is the smallest number, thus this one must be in the middle. So when I write them in order from least to greatest, I want to write 9,028,000 and then semicolon. I am writing 9.2 times 10 to the 6th because that's how it was given to me, semicolon, and then 93 million. I don't have enough space to write beyond there. So what do we put in between them? Semicolons. We put commas in our number to mark the periods. We put semicolons in order to differentiate from one number to the next. And when I ask for them from least to greatest, you should give me the smallest number first, the biggest number last. Okay. Look for the exponent that is the largest when they are in scientific notation. That is your largest number. If 2 exponents are the same, then you have to look at the constant in order to determine which number is bigger or smaller than the other one, so that you can put them in order. Easy enough? Any questions, sir? Need I go on with that? Awesome. Let's go on then, please. Oh, let's see. We talked about computing. Here, we did this one, right? Yes, no? We did not do this one together? Okay, then let's do this one together, and I've got another one to do together with you. 2.4 times 10 to the negative 4th, all raised to the 2nd power. I was able to get through a couple more examples with some classes than others. So 2.4 times 10 to the negative 4th, all raised to the 2nd power. What should we do with that 2 that is out there outside of the parentheses? Evan, what should we do with it?
Distribute it.
Can you tell me what I should write, please?
2.4 squared times 10 to the negative 8.
Times 10 to the negative 8. Very good. Like how I made that parenthesis. 2, and there we go. So 2.4 squared times 10 to the negative 8. Now, without the use of a calculator, very quickly come up with 2.4 squared, please. Without the use of a calculator. 5.76 times 10 to the negative 8 power. Ladies, gentlemen, is that in scientific notation?
No.
Yeah.
Is it in scientific notation?
Yeah.
Yes? Then we are done. Remember we talked about the other day, if it's not scientific notation, we're going to have to put it there. Perhaps the next one we can do that way. Okay?
So,
If it's already in scientific notation, you're done. Okay? So we did the 2.4 squared. We had the negative 4 times 2, so we had our 10 to the negative 8.
wait, so that wasn't an X, was that?
This is part of scientific notation. That is not a variable. It's a time sign, and I expect you to use next for that time sign. That's how scientific notation is written. Okay? There are no variables in there. Anybody else? Please do not use a multiplication dot. Use an X. Let's look at this one. Ooh, division. Yes. 2.4 times 10 to the 5th divided by 2.5 times 10 to the negative 5th. You may not have any power of 10 left in the denominator. You must move your powers of 10 up to the numerator. So what will happen to this power of 10 when we move it up, please? Jack?
It will add 5 to the, add 10 to the.
So it becomes 10 to the,
10.
it becomes 10 to the, what does this change to, Jack? 5th. That's what happens to it. It becomes 10 to the 5th. In just a moment, we'll finish it up, okay? So it becomes 10 to the 5th, and in the denominator, I still have the 2.5. I haven't done any other math except move that 10 to a power up to the top. It becomes the opposite exponent of what it was. What if that were a positive exponent in the denominator? What would it be when you move it up?
Negative.
Become negative. Awesome. Okay, 2.4 divided by 2.5. For the sake of time, I'm going to let you use your calculator for just a moment, but don't plan on that on your homework. 2.4 divided by 2.5. Raise your hand, please. Dankeschön. Kayla. 0.96. You guys agree with her on that?
Yeah.
Times 10 to the, Jack moved that 10 to the 5th up, so now we have 10 to the 10th. Okay, is that scientific notation?
No.
No. All right, now remember what we talked about yesterday. We're going to look at just this number and write it in scientific notation. Just that number. Evan.
9.6 times 10 to the negative first.
9.6 times 10 to the negative first. And then I'm going to attach the other times 10 to the 10th. What should we do to the exponents?
Yeah.
Add them together. So class negative 1 plus 10 is?
9.
9. So we're going to have 9.6 times 10 to the 9th. This is our final answer. I do that little intermediary step because there are many students who don't know, should I add, should I subtract, what should I do? I don't know what to do. And this makes it very simple. Always take that number that's not in scientific notation and write it in scientific notation, just that constant, and then attach the rest of your powers of 10 and finish it up like you normally would. Add them.
Do you have to show that stuff?
Technically, no, you do not. Okay? If you can do that in your head, fabulous. I know that the majority of the students out there generally cannot, but there are some of you who can. Okay? But what I've run across is that normally students don't know what they're doing, so I'm trying to help them out. Okay? Don't get it wrong on my test. No partial credit if it's wrong if I don't see any work, though. Okay? Anybody else? Good. Let's see here. More examples if needed. Do we need another one of this kind?
No.
No? How about another one of this kind?
No.
No? Another one of this kind. Nope, we're good to go.
Wait, can you
Go back to
just
this.
add those?
You add what? Ooh, maybe we better do this one. Okay, what operation is being performed up here all the way across? Multiplication. So I get to choose what I want to multiply. I want to multiply 1.1 and 4.2 together. First, 1.1 times 4.2. Okay, calculator should not be being used at this present time. We did that for that division just for the sake of time there. Spent, Luke?
5.04.
5.04, exactly. Whoa, I still have my marker on here. 5.04 times 10 to the class 9. Is that scientific notation?
Yes.
Fabulous, we're done. See how that works?
Yeah.
It's all multiplication. All right. Now, we're out 10 minutes early out of this class today, and your class is longer than what I'm going to have tomorrow, if we have school tomorrow. So, yeah, I know Valley's out,
We're
so.
not gonna have school Thursday or
Okay.
Friday.
Oh, heaven.
10 feet of snow.
10 feet of snow.
Ladies and gentlemen, oh, some year you can look back and listen to that and go, yeah, we were so silly to think that.
You mean me?
Evans are meteorologist.
I was the one that said that. I was joking.
Alrighty. Do you want any other examples along the way here? Are we good to go? You'll be able to do your homework? Okay, I'm gonna stop this. Okay, so we've determined that 5.04 is not the correct answer. It is 4.62. Is the times 10 to a power still good?
Yes.
Alrighty, so we gotta be careful in our multiplication. Thank you.